Welcome everybody. Welcome to our channel Point Basics, and today we will start our video number 3 for class 10 chapter electricity question bank slash numerical series. Till now we have done two videos in this series, and we have made around 5 to 6 videos in theory part of this chapter. So you can find out all of those in on our YouTube channel, and there is a playlist named Class 10 Physics where we have covered physics chapters in a quite a bit of detail with a lot of questions and numericals related to that chapter. So you can look them out, and if you find these videos any helpful or useful, then please consider liking these videos, sharing these videos, and subscribing to my channel, because more you share, more you subscribe, more we feel motivated to make such content, and it is a zero cost way for you to support us. So please do share and subscribe, and if you have any doubts, then you can ask in comment section. So with this, let's start today's video with our second exercise. In our first exercise there was 10 questions or 20 questions, sorry, and we covered those 20 questions in two videos. Now today we will going to cover our second exercise, and it has some questions. We will see in future that how many there are, but today we will start from question number 1. And let's start question number 1. So in question number 1 it is mentioned that electric bulb has a power of 40 watt. So power is 40 watt and potential is 220 volts. So we have to find out current, and formula for power is VI. So P is 40, V is 220, and here is I. We get I is equal to 40 by 220. So it is 2 by 11 ampere. You can calculate in ratio also. It will be 0.17 ampere something. So question number 2, into bulb is rated as 250 volts. So potential is 250 ampere, current is 0.4 ampere. So power is VI, means 250 into 4 by 10 equal to 100 watts, and resistance you can find V is equal to IR. So V is 250, I is 0.4, and here is R. So R is 250 by 0.4 for 10. So this goes to 5, this goes to 2, 1 to 5, 625 ohms is the value of resistance. Question number 3. So here supply is given, supply voltage is given 220 watt, and current is given. We have to find out power. It's question this question is similar to as question number 2. Both values are given and we can find out power. So question number 4 is also same. Voltage is given, current is given, so we can calculate power. Now question number 5. In 5 we have to calculate current, where power is given and voltage is given. So power is given 920 watt, voltage is given 230 volt. So power is equal to Vi, and from this I is equal to P by V, 920 by 230. So 92 by 23 equal to 4 ampere is value of current. Question number 6. Electric lamp is connected to 12 volt battery. Current is 0.5 ampere. We have to find the power. So voltage is given 12 volt and current is given 0.5 ampere. So power is Vi. So 12 into 0.5 is equal to 6 watt is the value of power. Going to next question 7. Calculate the power used in 2 ohm resistor. Each 6 volt battery in series with 1 ohm and 2 ohm, and a 4 volt battery parallel with 12 ohm and 2 ohm resistor. So we are going to first solve part number A or part 1. Here we have a 6 volt battery in series with 1 ohm and 2 ohm resistor. So it's something like this: 1 ohm, 2 ohm, and this is 6 volt. So we have to find out first current going through these resistor. Now, as this whole circuit is a series connection, 1 ohm resistance and 2 ohm resistance are in series, so we can find out total resistance is 1 plus 2, 3 ohm, and from then we can apply Ohm's law. V is equal to IR, and from this V is 6, I is as it is, and R is 3. So from this I is equal to 2 ampere. So 2 ampere current is flowing through this and this, because in series currents stay the same. So from this now we can calculate the power. Now power is Vi, but we don't know the voltage across this 2 ohm resistance. Keep in mind that voltage will be different in case of series. In series current is same, voltage is different. In parallel voltage is same and current is different. So we cannot use this formula. We have to convert. We will put V is equal to IR, so it will come I square R. We have value of I, that is 2 square, and R is, we are using 2 ohm resistance, so 8 watt. For 2 ohm resistance power is 8 watt. For 1 ohm resistance power will be, as current is same, 2 square into resistance value 1, 4 watt. So this battery is delivering total 12 watt of power, 8 plus 4, and that you can check. For battery it will be Vi, V6, and current in total current in circuit is 2. So that you can check. 12 watt is here. Out of those 12, 8 watt goes to 2 ohm resistance and 1 watt goes to 1 ohm resistance. So this is part number A. Now going to part number B. So in B part, 4 volt battery in parallel with 12 ohm and 2 ohm resistors. So circuit will be like this. Here we have first resistance, here we have second resistance. This is 12 ohm and 2 ohm. So 12 ohm and 2 ohm. This is 4 volts. So now we have to find out power across 2 ohm resistance. So for that we will find value of current across 2 ohm resistance. As this is a parallel connection, so voltage across both of the resistance is same and equal to applied voltage, that is 4 volt. So V is equal to I1 R1 and V is equal to I2 R2. Here current will be different, voltage is same. So 4 is equal to I1, R1 is 12, and 4 is equal to I2, R2 is 2. So I1 is 1 by 3 ampere and I2 is 2 ampere. So again power is, now we can use we can use Vi or I square R in this, because here we know the potential across each resistance. I will show you by using both formula. For 12 ohm resistance using Vi, voltage is 12 and I is 1 by 3. So power is 4 watt, or using I square RT, 1 by 3 into 1 by 3, and R is 12. We made a mistake here. Voltage is 4 volts. So answer will be 4 by 3 watt, because circuit voltage is 4 volts. So and using I square R, IR, because R is 12, and you get the same answer, 4 by 3 watt. Now power for 2 ampere 2 ohm resistance will be, using Vi it is, V is 4, I is 2, is 8 watt, and using I square R, I is 2, so 2, 2, 2, and resistance is 2, is equal to 8 watt. So in this case total power is 8 watt plus 4 by 3 watt is the total power delivered by battery. So this was question number 7. Now going to question number 8. So in question number 8, power is given 100 watt and voltage is given 250 volts. We have to find the current and resistance. So power is Vi, implies I is P by V, 100 by 250, and it comes out to be 4 by 5 ampere. Now power is also I square R. So power is 100. I value we got it now. 4 by 5 into 4 by 5 into R. So R is 25 into 100 by 4 into 4, 25. So 6 to 5, 6 to 5 by 4, and it will be around 156.25 ohm. So this is question number 8. Going to question number 9. Calculate the power dissipated when current 4 milliampere flow through a resistance of 5 kilo ohm. So we had to calculate power. Resistance is 5 kilo ohm, means 5 into 10 raised power 3 ohm. Current is 4 milliampere, means 4 into 10 raised power minus 3 ampere. So power will be I square R. Squaring this will get 16 into 10 raised power minus 6. R is 5 into 10 raised power minus 3. Sorry, plus 3. So 16 into 5, 80. Minus 6 plus 3, so minus 3, or 8 into 10 raised power minus 2. What is our answer? Question number 9. So if you liking these questions, liking my videos, my work, then please like, share and subscribe. With this, let's move to next part. Question number 10. So resistance is given and value of voltage is given. So resistance is 30 ohm voltage is 240 volts. We have to find the power, and for power we have three formulas: I square R, Vi, and V square by R. We will use this formula now. 240 into 240 by 30, so it goes to 8. So answer will be 1600 plus 320, 920 watts. Now question number 11. A current of 5 ampere flow in the winding of an electric motor. So current is 5 ampere, resistance is 100 ohm, potential difference and power we have to calculate. So potential difference developed will be V is equal to IR. So 5 into 100 over 500 watt, and power is equal to VI. V is 500, I is 5, so 2500 watts. Question number 12. So voltage and current relationship is given for two resistance A and B. Determine the value of resistance and power dissipated through each resistance. So let us first copy me this diagram. So we know from the Ohm's law that V is equal to IR. So R is equal to V by I. Now for resistance A, we know voltage is 20 and current is also 20. So RA is equal to VA by IA, 20 by 20, 1 ohm. For resistance B, you can see the markings here. Here voltage is 16 and current is 5 ampere. So RB is equal to VB by IB, or 16 by 5. So we will get 3.2 ohm. We have the resistances now, but we have to find power. So power of A is equal to VA into IA, and VA is 20, I is 20, so 20 into 20, 400 watt. Power B is equal to VB IB, and it is 16 into 5 equal to 80 watts. So this is question number 12. Moving to question number 13. A hot resistance of 240 volts filament lamp. So resistance is given, potential is given, and resistance is given. We have to find out current. So we can use V is equal to IR. V is 240, I we don't know, R is 960. So I is 240 by 960. It will be 1 by 4 ampere. Moving to question number 14. A 12 volt battery is given. Load is given 40 ohm. Determine the current flowing in the load and power consumed and the energy dissipated in 2 minutes. So here we have heat and power, both we have to calculate. So first we will draw the circuit. Battery value is 12 volt. Here is load resistance of 40 ohm, and this is a complete circuit. So V is equal to IR. Potential across this resistance is 12 volt. I we don't know, R we know 40. So I is 12 by 40 or 3 by 10 ampere. Now what is power for this resistance? That will be Vi. Voltage across it is 12 volt and current is 3 by 10, so 36 by 10 watts. And this is power consumed per second. It is joule per second. So we have to find in 2 minutes. So in 2 minutes there are 120 seconds. So we will multiply 3 this 36 by 10 into 120, and our answer will be 360 plus 72 joules. So 234 joules. Okay, with this question number 14 is complete. Let's move to question number 15. A source of EMF of 15 volts supplies a current of 2 ampere for 6 minutes. How much energy is provided in this time? So potential is 15 volt, current is 2 ampere, and time is 6 minutes, means 6 minutes with 360 seconds. So power will be 15 into 2 V into I, 30 watt. And if we have to find out energy, we will multiply it by time in second. So 30 into 360, it will give us 00 joules, 10,800 joules. With this, question number 15 is complete. Let us move to question number 16. So question number 16 is visible on your screen. In 16th question, it is mentioned there is an equipment which takes 13 ampere as a current and 240 volts for potential. We have to estimate cost per week of the electricity if the equipment uses for 30 hours each week, and 1 kilowatt hour of energy is cost 7 paise. So in this type of question, when you calculate power, it comes out to be kilowatt or watt per hour, not per second. So it is has to be taken into consideration. So voltage is 240, current is 13. So power comes out to be 240 into 30, and it is 226, 3120 watt. So it will be written as 3.12 kilowatt, and by default it is in hour, so 3.1 kilowatt per hour. Okay, so in a week it is used for 30 hours. So this is for consumption for 1 hour. For 30 hour it will be 3.12 into 30. So this will be our total power for a week. This will comes out to be 9360. So power comes out to be 93.6. It is kilowatt. So now 1 kilowatt hour costs 7 paise. So cost for 1 kilowatt hour is 7 paise or 7 by 100 rupees. For 93.6 it will be 93.6. For this will be 7 into 93.6 by 100, and this can be calculated to 6 5.2 by 100, and answer will be 6 rupees and 55 paise. Cost will be something like this. Now going to question number 17. An electric heater consumes 3.6 million joules when connected to 250 watt supply and 40 minutes. So heat is 3.6 into 10 raised power 6 joule. Potential is 250 volts and time is 40 minutes, or 40 into 60 equal to 2400 second. And we know heat is equal to I square R into T, and this is power. So heat is equal to power into time. So if you divide heat by time, we will get power. So power is heat by time. Heat is 3.6 into 10 to the power 6 by 24 into 10 to the power 2. This will be 36 into 10 to the power 5 by 24 into 10 to the power 2. So this is 3 by 2, or 1.5 into 10 to the power 3 watt. So this is the power rating, and from this we can find out current, because power is V into I. So I is power by V. So I is power by V. We can write this as, so this will be 6 ampere. Question number 17. Question number 18 we will start. So when a current of 10 ampere flows through it, if the fire is on for 6 hours, determine the energy used for the cost of 1 unit of electric, which cost 7 paise. Determine the power dissipated by the element and the electric fire dissipated by element of the electric fire of resistance 20 ohm. So we have resistance of 20 ohm. We have current of 10 ampere. So power will be I square R, and this will be 100 into 20, or 2000 watt, or 2 kilowatt, and this is in per hour. For this type of question it is always in per hour. So for 1 hour it consumes 2 kilowatt. For it runs for 6 hours, so total consumption will be 2 kilowatt into 6, 12 kilowatt for 1 day. And cost for 1 unit or 1 kilowatt is 7 paise. So for 1 kilowatt cost is 7 paise. For 12 kilowatt is 7 by 100 into 12, or 84 by 100 rupees, or 84 paise is answer. Oh, moving to next question, question number 19. A business uses 3 kilowatt fires for an average of 20 hours per week. So fire rating is 3 kilowatt, and there are 2 fires. So total rating will be 3 kilowatt plus 3 kilowatt is equal to 6 kilowatt per hour. Now they uses for 20 hours per week. So for 1 hour we have 6 kilowatt load. For 20 hours we will be 20 into 6, 120 kilowatt load, and this is for fires for 1 week. Now there are 6 150-watt lights, so 150 watt into 6 light, 900-watt lights, 30 hours each per week. So we will multiply it by 30, we will get 2700, 27,000 watt, or 27 watt, 27 kilowatt for 1 week. So oh, total power will be fire plus lights. So 120 kilowatt plus 27 kilowatt, it is 147 kilowatt. Now cost is 7 paise per unit, means 7 paise for 1 kilowatt. So total cost will be 147 into 7 by 100, and this will be 10 rupees and 29 paise. 10 rupees and 29 paise is the answer. Now going to question number 20. So in question number 20, there are 3 fuses available: 5 ampere, 10 ampere and 13 ampere. State the most appropriate for the following appliance. Both are connected to 240 volts. So we have 5 amperes fuse, 10 ampere fuse and 13 ampere fuse. And purpose of a fuse is to protect the electric appliance when current increases beyond its values. So for 10 ampere switch fuse, 10 ampere fuse will stop working when current increases beyond 10 ampere value. So it will protect the instrument. So indirectly we have to find out that what is the maximum current allowed for that instrument, and we will choose according to that current. Suppose if we have an instrument of 6 an instrument which has current of 6 ampere, then we will choose a fuse of 6 ampere, right? We will show this in this question. So potential is given 240 volts, and toaster having power rating of 1 kilowatt. So power is given 1 kilowatt or 1000 watt. So here P is equal to VI, and I will be P by V, or 1000 by 240, and it comes out to be 25 by 6, so 1.6 something ampere. So for this type of instrument we will choose 5 ampere switch. Now power is giving for electric fire, it is 3 kilowatt. So now new power is 3 kilowatt or 3000 watts. So current will be 3000 by 240, and this will be 100 by 8 and 25 by 2, or 12.5 ampere. For this we will choose 13 ampere switch because its current rating matches approximately with 13 ampere switch fuse. So with this we have completed question up to 20, and remaining question we will do in next video. And as usual, if you have gained some knowledge, some understanding, some information from this video, and if you like our work, then please consider like, share and subscribe, because it helps and it is a zero cost way to support us. So please do like, share and subscribe. With this I'm signing off. We will meet in next video with more numericals and more questions. Till then, keep on studying. We will meet in next video.